The shortcut is going to nullify the quadratic formula for us. Because who wants to do quadratic formula? Okay? Nobody. Nobody. But first, let's go back to this. So what is the solubility of PbOH2 with a KSP of 1.2 to the negative 13th and a solution of pH 9? A solution with a pH of 9 has a concentration of OH minus, which is 1.00 times to the negative fifth. You'll see how to do that later. All right? I'm going to teach you what pH actually means in a chapter or two. Coming up soon. Actually, real soon. That's the next unit. So, here we go. Step 1. Write the equation. Right? So I have PbOH2, which is a solid, is going to be in equilibrium. Am I on the screen? Yep. With Pb what?
OH2.
2 plus. And OH minus what? Squared.
Good.
Right?
Good answer.
OH minus squared, because I got 2 of them. Yes? Right? So this means that 1.2 times 10 to the negative 15th is equal to the concentration of Pb2 plus times the concentration of OH minus squared. And we know one of these things, 1.2 times 10 to the negative 15th, is an equilibrium. I'm going to say equals at this point, not really equilibrium anymore. Equals x, right? Times, they gave me the other one, right? 1 times 10 to the negative fifth squared. So solve for x, and you're good. So molar solubility, the solid to their ions is not hard. You just basically seen, is it x squared or is it 4x cubed? Is what it comes down to when you're icing it. This one, no ice needed. Yes?
So what's the pH 9 thing for?
The pH of 9, the reason it gave me this pH of 9 is so we could determine what my concentration of OH was. We don't know how to do that yet. All right? They use this number to get this number.
Okay.
I'm going to try to do that next chapter. For us, this is what's important. So you'll know how to take this and turn it into this next chapter. Not hard.
Take what and turn it into what?
Take the pH and turn it into a concentration of OH minus.
Okay. But that's not an issue now.
So
No.
why don't you have to do the rice? Or the rice?
Because there's no equilibrium here. It's not. There it says nothing about equilibrium. It just says what's the solubility. What's the solubility in the solution? So there's no equilibrium here. This is just in a state. So you just sub it in. Boom, you got it. Yes.
Why did we use the equilibrium thing?
I don't know why I did that.
Oh.
Well, this is an equilibrium, right?
Oh,
It's an equilibrium,
okay.
but this is just equal to that. So I didn't have to write that. You could have just drawn an arrow. I mean, when you have a solid going to its ions, it's really just moving one way. But I draw the equilibrium, because as soon as you have any ions, it's going both ways. Okay? What'd you guys get for x?
1.2 times something.
Yep, 1.2 times 10 to the negative fifth. That's it for those notes.
Oh.
But I have a couple more ice problems that I want to work through with you to make sure
Not an icy fellow.
you guys know what's going on. So some more ice, baby.
I got 3.
You got 3? Great. Crush that one. So here we go.
Very bad.
Couple more problems before we wrap this chapter.
You got rice, I'm sorry.
We good?
Yeah.
Do you want to hear something kind of funny about the conference?
Yeah.
So there was a lot of snacks all around. Full-size candy bars.
Oh, that's dope.
Reese's, Skittles, yeah. Snickers,
Free?
yeah.
Oh, free?
You're like $2 at the concession.
I know. So like,
I would take
me and
that.
Mr. Knight kind of made it our mission to just get as many as we could. Because they give you like these swag bags. We were just every time we went by, we'd like just grab one, put it in. Like, got so much candy. Like it's
Good.
ridiculous. It was like adult trick or treat.
So Skittles candy.
I don't think that's what it was supposed to be, but that's how we took it. So much candy. It was a lot. Teachers like free stuff. Okay, here we go. Carbon monoxide reacts with steam to produce carbon dioxide and hydrogen. At 700 Kelvin, the equilibrium constant is 5.10. Calculate the equilibrium concentration of all species if 1 mole of each component is mixed in a 1 liter flask. A lot going on here. Where would you start with this problem? Let's do the R of rice. So for R, I'm going to have CO, which is a gas, plus what? H2O, which is a, be careful here.
It's steam, I'm smart.
I said steam on purpose. Gas
Oh my goodness.
is in equilibrium with, which is CO2 gas plus diatomic H2 gas. So here we go. Initial concentration of all of these things. All right? Initial concentration. It says calculate the equilibrium concentration of all species if 1 mole of each component is mixed in a 1 liter flask. So I'm starting out with how many molar of this? 1 molar. What about this? 1 molar. What about this? 1 molar. What about this? 1 molar. It says of each component. Of each component. Now what?
This is the C.
Which one?
That's a great question.
CO2.
Do we know which way this shifts?
Yes.
It says carbon monoxide reacts with steam.
To produce carbon monoxide.
You're just reading the thing.
We're waiting for you to say something. Yeah, we're just talking until you answer.
You?
Oh, wait.
Yeah?
Acid base thing?
Nope.
H is on the
Nope.
Don't.
We can figure it out.
Okay.
All right? Because we were given what? What is this number here?
The constant 5.1.
Yep. you said
That is my K. Agreed?
Yeah.
Oh.
Could I solve for Q?
Yes.
I could,
I don't know how.
right? I could. Because Q, remember, Q is the concentrations at the beginning. Do I have initial concentrations?
Yes.
I do. So Q is equal to concentration of, for my Q expression, CO2 times the concentration of H2 times the concentration of over the oh yeah, you're right. These are gases. Good call. See?
Almost tripped us up there.
These are gases. Over concentration of CO times the concentration of H2O. Now, I gave some pretty easy numbers here. Q equals 1 times 1 over 1 times 1, which equals
1.
1.
I was going to say 2.
7.
Shifts. Right.
Therefore, Q equals 1, which is less than what?
5.
K, which equals 5.1. If Q is less than K, it shifts.
Right.
There it is.
What? Me saying right was just
So it shifts to the right.
I said right.
That is what you do with Q. You have to sometimes solve for Q to figure out where your plus X is and where your minus X is going. This is full circle right here. So, if it's shifting to the right, what? This chapter? All right, we haven't really, I've told you what Q is, but this is the first time we've really applied it. Okay? So, if it's shifting to the right, what am I doing on this side, minus or plus X?
Plus. Minus.
I'm using up reactants, right,
Yeah.
to make products,
That's what I meant.
because it's shifting to the right. So there's my minus X. So my E, 1 minus X, 1 minus X, 1 plus X, 1 plus X. Next step. No. Because I want to know what are the equilibrium concentrations of all species.
Yep.
Now what's my next step?
Right.
Write the K expression, right?
Yeah.
Which we know is the same as the Q expression, yes? But we'll write it out anyways. So K equals CO2 times H2 over CO times H2O.
I thought it was Q.
It's the same.
It's the same.
K and Q are the same thing, but just at different parts of the equation. Because now I'm at equilibrium, right? Q is the initial, same exact equation, but at a different part of the equation. Beginning, equilibrium. If I'm at equilibrium, it's K. If I'm starting, it's Q. So, we know that K is what? 5.10 is going to equal 1 plus X what? Are you guys okay with that?
Yeah.
Because it's going to be 1 plus X times 1 plus X. Yes? Over 1 minus X squared. What am I going to have to do to those things? Square root, right?
Interesting.
Why would I not take the square root of both of those?
Couldn't say because that looks too complicated.
It's easy.
Let's just.
If I take the square root, what's the square root of 5.10?
Give me
That's not what my.
I like to make my math easy.
I would have factored it out.
Why?
I don't know why.
Yeah, I would have.
That's just the way we're
If I have a square over a square, I'm going to square root it. What's the square root of 5.1?
That goes against the
We've
law.
learned the math. We haven't learned to be practical with
This is the practical.
2.26.
2.26 equals 1 plus X over 1 minus X.
not fair.
Now, you've got some nice work. What are we factoring?
Not factors.
Now I'm going to multiply across, right?
Cross multiply, good over 1.
Yeah, so I'm going to say, when I multiply both sides by 1 minus X, right? That's going to give me 2.26 minus what? 2.26x equals 1 plus x.
And then
Now solve for x.
take it to the other side.
Now solve for x.
3. We're not on the same page there.
What?
I don't know.
I don't think that's it.
It is not 1/3.
It's 1/3.
It's 0.38. I had 0.387. Either one's fine.
Basically, yeah.
All right, 0.387 molar. Now are we done?
I rounded in my head.
No, because I want to know the concentration of all the species. So we know that the concentration, sorry, because it's a gas in a bracket. CO is going to equal the concentration of H2O, right? Which is going to equal 1 minus 0.387, which is what?
Oh, this one is.
0.613 molar. And I know that the concentration of CO2 is going to equal the concentration of H2, which is going to equal 1 plus 0.387, which is 1.387 molar.
Wait, what?
That's equilibrium.
Oh,
That's equilibrium. So that is your concentration of these things at equilibrium. So, not hard work,
What is equilibrium?
just work. Yeah.
So the only reason we're doing the thing with like the products over the reactants is that because it's a gas?
You always do products over reactants,
Okay.
no matter what.
So how is this one different than the other problem?
The only thing that's different because on this one is because we're using the parentheses instead of brackets because it's a gas.
Is that the only reason we use parentheses?
That's it. When you have all gases, use parentheses. If not, you use brackets. Yeah.
So, like, what happens during equilibrium? What is equilibrium?
What is equilibrium? I'm going to show you tomorrow in lab. All right? It'll make more sense tomorrow when you see it in lab.
Yeah.
Equilibrium is when, remember how I showed you the graph? How they kind of like go like this and become equal? That's when your amount of products and reactants are being produced at the same amount. It's really weird how I'm going to show you tomorrow. It blows my mind a little bit too. It's something really simple, but easy, fun lab. Here we go. Last one. Last one. Gaseous, NaCl, decomposes to form the gases NO and Cl2. At 35 degrees Celsius, K is 1.6 and 10 to the negative fifth. An experiment where 1 mole of NaCl is placed in a 2-liter flask. Oh, snap. This is so crazy now. All right? What are the equilibrium concentrations? What are the equilibrium concentrations? Step 1, R. My reaction is NaCl, which is a gas, decomposes. Still equilibrium. We're just gonna write equilibrium from this point forward. All right, decomposes into what? NO gas plus Cl2 gas. Am I ready to start icing this thing?
No.
Why not?
Balance.
It's not balanced.
Oh, isn't it? Look at it.
Just think about all the things look at. Would you look at that? Just look at it. Think of all the things we are bringing into this now. So I'm going to put A to here, to there. That's balanced. Oh, yeah. Oh, yeah. Initial concentration. What is my initial concentration of NaCl? Are you guys okay with why that's 0.5 molar?
No.
How many liters? 2. How many moles? Moles per liter. 1 divided by 2 is 0.5. Right? So my initial concentration is 0.5 because 1 mole for 2 liters, mole per liter is molar, 0.5 molar. What's my initial concentration of my products? Yes. Why?
No product yet.
Because it's an experiment.
No.
We haven't done it yet.
It's decomposing. If it's decomposing, I don't start with any products. Right?
Yeah, yeah.
If it's decomposing, there's nothing on the right. Kale's like, yeah, I'll be. It's decomposing, so there's nothing to start with on the right. Exactly. Change. Which way is this shifting? To the right. Why? Because it's decomposing. Right? What is my C here? 0.5 minus 2x plus 2x plus x. Can somebody grab the door? Yes.
The only reason we had to do Q is because it started with initial concentrations of both sides.
On this one?
Yeah.
Right. And if you don't know which way, there was no way to know which way this is shifting. So you have to just think, like, the gases are all there. You had to figure out which way is it shifting. Brendan.
Can you give me a quick refresher on what the step C is and what making fun?
Step C?
Yeah.
So C is the change. So how are your reactants and products changing from initial conditions to equilibrium? What's the change they're going through? Because there's a coefficient of 2 here, this is going to be decreasing by 2x. Because there's a coefficient of here, it's going to be increasing by a factor of 2x. 1 is going to be increasing by a factor of x. I know it's increasing because it's shifting to the right. I'm making more products. This has to be decreasing because it's shifting to the right. If it shifted to the left, then this would have been plus 2x minus minus x. So the C is just the change.
Is there a certain reaction that we know is going to be like a shift left?
You'd have to figure that out based on what you're given. If it shifts left, it's going to be Q is greater than K. Q is going to be greater than K. A lot of these are going to shift right, but you'd have to figure out your Q. Yes?
If it shifted to the left, could you just switch it in this and then do it like you did before?
What do you mean? Change it.
Like NaCl's on the left, that's on the right. If you just flipped it because it's in equilibrium, could you just do it the same way?
So you're saying write this on this side and this on that side?
Yeah.
No, because that would change your K expression.
So it has to be a certain way.
You have to write it like this because your k has to be NO squared over NO squared times CL squared over NOCL squared. You can't switch it because you're changing your k expression. Right? You would not switch it. Do not do that. Don't do that. Actually, let me think about it. It might work. It might work because remember how we did the k's? It'd be like to the half power. It might work. I'd have to figure that out. It'd be 1 over k. It would.
You just have to know that and use a different k value.
Yeah, but don't do that. Don't do that. No reason to do that. That's like adding extra math. So I think that actually would work. It would work. But don't do that. Don't do it. All right? I showed you how it would work. It's in the notes. Right? If you flip the equation, we said that that's what? 1 over k?
Yep.
Yeah.
What are you still eating?
Okay. Equilibrium. 0.5 minus 2x. 2x and x. So I have my equilibrium. Next step is write my k expression. K equals parentheses NO squared times parentheses CL2 over parentheses NOCL squared. So many things to get right. So many things to get right. Do you have your 2x's here? Do they become squares here? It's not hard. It's super repetitive, actually. Once you do a couple of these, it's the same thing every time. Same thing every time. Next step, sub in what we know. Sub in what we know. So I know my k is 1.6 times 10 to the negative fifth is equal to 2x squared times x over 0.5 minus 2x. That whole thing is going to be squared.
Does it matter that it's like at 35 degrees?
That's not important for us. All right? It's not important. Now, pause. Stop. Do not do quadratic formula. Do not graph it. Do not pass go. Do not collect $200. No. That's not going to work. It would work, actually. You could. You could. All right, if you want some half powers. So sure, you could do it like that. Would you? No. Allison might, but that's fine.
X would be the thing.
Yeah, you're right. So here is the shortcut. There is no quadratic formula that you have to do on this problem. Here's why. This is a conceptual thing that you have to understand. All right? This is a little bit conceptual. Your k is what? 1.6 times 10 negative fifth. Is that a big K or a small k? That's tiny.
Really small.
Which means it's barely going to go towards what? It's barely going to shift towards the products. Agreed?
Yeah.
Because it's such a small k. Head nod if you are okay with that conceptually. Yes?
If it's negative, is that what determines if it's left?
If what's negative?
Okay.
No. The way it's shifting is, this was just based on, it was decomposing.
Okay.
So, because it's decomposing, it's shifting right, or you just compare it to cube. Or we'll just say it moves forward. It is a very small k. If it is a small k, we know it's barely shifting to the right. So therefore, when that happens, I can assume that this x becomes what? 0. All right?
Poor K.
Poor k? Because it's barely going to the right. If it's barely going to the right, then this x is basically insignificant statistically. You could solve it with quadratic formula, or you could make the 0, and guess what? You get the same answer within like 0.01. It's the exact same thing.
Just that X or like
Just this x on the bottom.
Don't do it.
Yeah, why that?
Why?
Is it because it like doesn't change? Really?
Because it doesn't change. Because it barely shifts, it's almost the same thing on both sides. So there's really no change, is what I'm saying. When you have a small k, this x is assumed to be 0. Baron.
How small is small enough for K for this to be able to work?
Basically any negative exponent.
Okay.
Any negative exponent. Because they're really, here's the thing, this really actually, because it's not shifting to the right, this change is really basically not happening.
No, wait, how small is small enough?
Negative exponent on K,
Oh, any negative exponent?
essentially. But you'll know. All right, it's going to be negative 4 or
What if
5.
it's like the other way, but it's really big?
If it's really big, well then you have to do this.
Oh.
Because it's going to be a huge change.
It's the same X.
What?
Yeah, it's the same X.
But this is the one that's changing. All right?
It's not changing. Isn't that what X is?
I mean, yeah, but it all is based off of your reactance. Because it's barely shifting to the right, this x is 0.
Is this like end behavior?
All right?
It's the same X.
It is the same
I
x.
feel like this is limits.
It's still the same x, but this is my minus, the one that you're subtracting.
Looking at the code.
You can't just make it all 0, because then it would work.
But if it's basically
It's
zero,
it's
it
based
is.
off of the change. I'm saying the change.
Yeah,
so
but if
this
that
X-
change is basically zero, then don't the other ones change basically zero?
Yeah, but you have to do
When you
this.
do it for the X, then
Well, then why
CL2
you
would
can't-
be the
you can't do
smallest
this,
change
all right?
because there's not a 2 in front of it.
Because I'm making these, right? I can't have 0 on this side if I'm making something. Would that make any sense? If I'm making something on this side, can it be 0? No. These cannot be 0 at the top.
How does it work if you make 1 0 but the rest not 0?
That's what you do.
It's a cheat code, just accept it.
All right? I would suggest you read further in the book if you'd like to know deeper. There's about 4 pages in the book about this.
You can read that.
All right? But here's the thing that's important. If it is a small k, this becomes 0. Do it. I want you to graph it and do it with this as 0 and see what your 2 answers are.
Is just the bottom
I just
at
wanna-
2x 0?
Just
Wait,
this
what's
x
the answer?
on the bottom. Well, let's finish it. So that means that 1.6 times 10 to the negative 5th is equal to 4x cubed over what?
0.5.
0.5 what?
Squared.
0.5 squared.
So it's only the bottom 2x that gets
And-
cut off.
Probably another reason is because this is cubed. So it's a larger factor on the top why you're not making that 0. But when you're just subtracting, you're basically subtracting 0. When you're subtracting 0, this number is going to stay the same. 0.5 minus 0 is 0.5.
Yeah.
So what do you get when you do it like this? X equals,
I'm almost there.
Times
0.01.
yeah, 1.0 times 10 to the negative second, right? 0.01 molar. Now put it in your calculator. Well,
good answer.
let's go up here and finish it first. Actually, put it in your calculator and what do you get?
Including 2x or no?
Including the 2x.
Okay.
Do the same thing, graph it, and what do you get? We're making the x on the bottom 0 because that's the change.
Because it's going to the right.
Right. It's shifting to the right, but it's actually such a small k, it's not really changing. What did you get when you put it into your calculator?
It's still working.
Still working?
It's very slow.
I don't doubt.
Don't doubt it.
Sean's like, I'm good. If I don't have to do a quadratic formula, I'm out. Which you should be.
Basically 0.01. It's 0.0097.
It's the same number,
Yeah.
right? It's the same number. Because you're basically subtracting 0. That's how that works. When you subtract 0, it doesn't change. So you assume that this x is 0, nothing is changing, you get the same number. Let's finish it off. Concentration of NaCl is equal to what? It's going to be the same, right? With sig digs, it's going to be 0.5. Yes? It would be parentheses. All right? Yes, They will take points off if it is all gases.
I'll just make one like halfway in between so they can't tell which one.
Yes, dude.
But then what if they decide to take the they're gonna not give you the benefit.
No, it's a rubric. Like they won't. It probably won't. There probably won't be gases on the test this year. It'll probably just be molarities. Why? Because there was last year. So
What
that
if it
works.
was a curveball?
They don't want students to like look at last year's test and study that and be like, if I do that, I'll do well on the test. Like that's not what they want.
Yeah.
Yes.
0.52.
0.5 minus 0.
But the x is 0.01.
It'd be point. If you sub in for the x, it's actually 0.48. This is 0.01. 0.01 times 2.
Wrong way.
It'd be 0.5.
That's what I'm asking.
It's when you subtract, it's how many the least amount after the decimal. So I have 1 after the decimal, 2 after the decimal. So that'd be 1 after the decimal. When you subtract numbers, it's the least after the decimal that you keep in your answer.
So you don't have to subtract, I thought you were just gonna take the same.
Right. Even if you did subtract it, it'd be 0.48, which statistically is still 0.5. Which also shows why this is 0. It's not changing. Concentration of NO. Concentration of NO is going to be 0.02. This is molar. Molar. Concentration of Cl2, or pressure of CO2, I guess we should say, is going to be just 0.01, right? 0.01 molar. 0.01 molar. Yes.
Is that person still coming in and talk to us about the?
Yes. Dr. Bonvoy will come in,
Yeah.
talk about the AP test.
I said the
So, if it's a small k
come back with
and you're subtracting an x on the bottom, it's 0. Yeah. The x is on the top, you cannot make 0.
second choice.
That's it. That's the chapter. So, you guys can start book problems. You got 15 minutes left.
Mr. Howley, do you have to